Welcome to qnawire.
In this problem, we have a setup Q1, Q2, and their separation is 13 centimeters. We have also an interested point over here, point P, and the distance between P and Q1 is 5 centimeters. The distance between P and Q2 is 12 centimeters. So for part A, we have 4 configurations of different signs of Q1 and Q2. So we want to label the electric field for different configurations. So suppose we have positive and positive. Then for the point P, this is pointing up, this is pointing to this direction, and for that one is pointing to this direction. So the Y component has to be pointing up. And if we have positive and negative, then for the interested point, because Q1 is positive, then it's pointing to this direction. For Q2 is negative, so it's pointing to this direction. In this case, the X component is not zero, as you can see clearly. For third case, negative and positive, we have this point. So because Q1 is negative, so the electric field is pointing to this direction, and Q2 is positive, so it's pointing to this direction. In that case, the X component is not zero as well. And for the last case, if we have negative and negative, so we have 2 points. We have this interested point over here, because Q1 and Q2, they are both negative, so the electric field is pointing toward them. In that case, it is possible to set the X component being equal to 0, and the Y component is pointing down. Okay. And so for part B, the only possible case is just the negative and negative. For part C, we want to find out the value of Q2 and the value of the electric field. So we already know that at point P, the electric field is pointing down. So there is no any component along the X direction. So in that case, E induced by Q1, which is E1 equal to negative 1.4 pi epsilon naught. We just look at the X component. So E1X times Q1, sorry, not Q1. Yeah, Q1 divided by the separation between the Q1 and the point P, which is 5 centimeters squared. So this is E1, and because we're interested in the X component, so we need to times the factor 5 over 13. Okay, and the X component induced by E2 is sorry, we should not say Q1 here. We should just utilize the value of Q1. So right here, it's simply 3 microcoulombs. And for E2X, it equals negative 1 over 4 pi epsilon naught. Q2, we just look at the magnitude, okay? So divide by 12 centimeter squared and times 12 over 13. So this factor gives us the X component of E2. So we have E1X. Let me see, E1X equal E2X, right? Right, let me see. So E1X is pointing to this direction. E2X is pointing to this direction, right? So this one should be positive, right? So the relation we will have is E1X plus E2X equals 0, okay? And you can actually solve for Q2 equal to negative 7.2 microcoulombs. And then we can try to figure out the magnitude of the electric field at point P. So the electric field will be equal to E equal, because in this case, we just look at the Y component. So this becomes negative 1 over 4 pi epsilon naught times 3 microcoulombs divided by 5 centimeters squared and times 12 over 13. So this gives us the y component, okay? And a minus 1 over 4 pi epsilon naught times 7.2 microcoulombs divided by 12 centimeters squared and times 5 over 13. So the final value is 1.17 times 10 to the 7th Newton per coulomb.